Hey everybody, I'm Mark. Welcome into my studio. We're gonna spend most of the time today over here in the corner of the studio where I keep my 3D printers, and specifically because I wanna talk about my Voron 2.4. So if you've been following along with the channel for a while, you might know that this thing has been out of commission kind of off and on for the last like 5, almost 6 months. And I think that it's finally fixed. And so we're gonna do some testing today to make sure that that's the case. And then I can declare the issue that I had with this thing finally fixed. And the issue was that when I built this Dragon Burner tool head to go on this guy to replace the stealth burner that came with it, there's a build series of videos on the channel. You can go back and look at those if you're interested in the process here. But one of the main things that I wanted to do with this tool head was to try out a new tool head board that had come out from LDO that was called the Nitehawk-36. And so this Nitehawk-36 board, which is on the back side of the tool head here, the trick that makes it special compared to other options is that it uses USB to talk back to the Raspberry Pi that's running Clipper in the electronics compartment down below here. So there's a single USB cable that runs from below up to here, and that should be, in theory, all that you need to run up to your tool head to do everything that you need to do up here. And additionally, besides just controlling the things on the tool head, it has a pass-through connection where you can connect other USB devices out of the back of this thing so you can chain other things onto it. And so what I did for my Z probe and for my bed meshing, I got a Beacon Probe, which is down here on the bottom. Again, you probably can't see it on the video shot, but that runs with USB. And so I made a special custom cable that chains from the Beacon up to the Nitehawk. And again, then we just have to have the single USB cable. And in theory, everything here should work. In practice, what happened was we got this thing built. I got it put in the printer. I used it for 3, maybe 4 weeks. And then suddenly I started getting these intermittent disconnect issues. So either the Nitehawk or the Beacon, or sometimes both, Clipper would report that they had disconnected and they were losing their USB connection basically back to the Raspberry Pi. And it was very confusing to me. I didn't know what was going on. I thought maybe I had done something wrong. I thought maybe I had a bad USB cable, so I made my own. That seemed like it fixed the problem very temporarily, maybe 2 or 3 weeks again, and then it started happening again. Come to find out, other people were also reporting similar issues. LDO decided that there was an issue with the Nitehawk itself. They issued a recall. The issue was actually related to heat. So if you were printing in an enclosure like I've got here, and if you were printing at high temperatures and your chamber was heating up hot enough, that would be the thing that would often cause the USB disconnect issues with the Nitehawk. And so they've fixed that. They've sent out replacements to, I think, everybody at this point. I know I got mine about a week and a half ago, something like that. And so I've dropped the replacement in here. I apologize, I didn't actually film any footage of me doing the replacement itself. It was very straightforward. The footprint of the new board is the same as the old, and all of the connectors are in the same spots. So everything just plugs right in. It was just a drop-in replacement. So it should be good to go. I've done a little bit of preliminary testing here. I closed the chamber, I just heated it up. I didn't actually print anything, left it that way for a few hours, and nothing disconnected. So I'm very hopeful that the problem really is fixed. I believe that it likely is. But for today, what I wanted to do is spend the day using the printer to print something interesting at high temperatures. And then by the end of the day, hopefully we'll have enough hours on this thing with it heated up that I can declare, at least for me, that it seems like that this has fixed the problem. And so the project I have in mind, I actually want to print with carbon fiber infused filament. So I've got this roll up here of Polymaker Voron that I picked up recently. This will be my first time printing with any sort of carbon fiber filament. That was another thing with this print head that I wanted to do, was install a hardened steel nozzle. And so this is the first print head that I have ever had that has the ability to print these types of more exotic types of filaments. And so I've done a couple of test prints with this thing, with this filament. I've done like a flow rate test and a temperature tower just to make sure I've got my settings dialed in correctly in Orca Slicer. I also have a video here on the channel, I'll link in the corner now if you're interested, on kind of the process that I use for tuning a new filament. I didn't do the entire process for this particular filament. I only did temperature, flow rate, and pressure advance, which are the big 3 that I recommend doing. And then there's some other things you can do if you really want to dial things in. I didn't do any of those. So it has printed a couple of things, small pieces, successfully. But again, I haven't printed for a long time yet with this thing at high temps. And so that's what I want to do today. So the project for today is I found on printables.com a very cool case for the Mac Studio computer, and Mac Studio is what I use here in my studio for recording and editing all of these videos, but I wanted to make some modifications to it. So we'll jump over to the computer, I'll show you this case and the modifications that I've made, and then we'll get this thing started printing one piece at a time. Like I said, I think the whole process is going to take most of the day, maybe 10 or 12 hours total of printing, so that we can really put this thing through its paces and make sure that it prints this carbon fiber filament, with the high temperature nozzle and everything works well, and we don't get the Nitehawk disconnecting. So that is the plan for today's project. Let's jump over to the computer. I'll show you what we've got to print, and then we'll get the first print started and we'll see how it goes. All right, so here's a look at the original inspiration for today's project. This is by Because Chemistry over on Printables, and huge thanks to them, because not only did they share this project here, but they also, I reached out to them and asked if they could share the original CAD files for this, and they were gracious enough to do that. And so I started with their CAD files, and I've made some modifications. I will post a version, my remix of this on Printables, and I'll link to that in the description of this video. And then you can get back here to their original one if you're interested. But this is a case for a Mac Studio. It's got this big cutout on the side that allows the bottom part of the Mac Studio, where the venting happens, to be exposed so that you still get good airflow. But it tips the Mac Studio up on its side, and then adds this nice decorative front cover with openings for access to all of the ports and such. The back side is just open like this. That seems fine, and the other side has an Apple logo on it. And so what I wanted to do is I have an external USB enclosure. It's a hard drive enclosure, and it has a bunch of additional ports on it that is designed to stack on top of the Mac Studio. So if you imagine over here on the right-hand side, which would be the top of the computer, having another piece that has the same footprint, so it's the same sort of square with rounded corners. But what I need to do is make this whole case wider to accommodate that, because I want to put both of them in here together. And then on the front side, I will have a whole other set of ports that are available over here on the left-hand side of the front as you're looking at the computer. And so, like I said, Because Chemistry was kind enough to share their original CAD files. They were in Fusion. I loaded them in Fusion and exported them as step files not too long after, so that I could load them into Plasticity, which I realize is not a real CAD program. It's more made for like artists and designer type people to do 3D modeling, but I use it for some of my Gundam stuff that I do, and I've gotten used to the workflow. And for a simple project like this, not having the standard CAD measurements and constraints and things like that didn't bother me too much. So I loaded it over in here, and here's what I've come up with. So the whole case is wider, like I said. There's this big rectangular opening here that'll be on the front side for access to all the extra ports that my external USB hub/enclosure thing adds. And that was the big change that I made. I kind of reworked the detailing on the front here. I used the same sort of circular sphere cutout pattern that the original designer had used, but I just rearranged them a bit, made them only here in the center part so they're not overlapping these cutouts or anything like that. And then the other big thing that I changed was on the feet and the handles. Let's see, I'll show you this handle here. I made little cutouts here, or little circular openings, so that we can put heat set inserts in here. So the original design had these handles and the feet just being glued in place, like with super glue or something. But on the off chance that I grab one of these handles, which I think are just meant to be decorative, and actually pick the case up by the handle, I didn't want it to be just held on by super glue. I didn't want the whole thing to fall apart and drop my computer. And so I wanted them screwed in place. So I have modified everything so that M3 screws will fit properly, and we can put heat set inserts in all the right spots, so that this thing can actually be screwed together and held together very securely. And that way I'm not in danger of having it fall apart and dropping my computer in the future. And so I think what I'm going to do first of all is print this right-hand side of the case, which is the bottom of the computer. Because it's got this big circular cutout, I think it uses less of the filament than anything else. and I'm not completely sure that I trust all my settings and everything. I don't want to waste filament because these rolls of Voron filament are quite expensive, so I don't want to have to buy another one. So we'll start with this one. I'll keep a good eye on it to make sure as it's printing that everything looks okay. I've loaded it into Orca Slicer over here, so this will be our first print for today. I'm going to go ahead and slice it. I'm using the custom profile that I created for this filament, and then just my standard 0.2 millimeter layer height quality setting that I have, that I've dialed in for Orca Slicer here for my Voron. So slicing that, it looks like it's going to take just over 2 hours to print. Yeah, simple enough. Like I said, I'll keep a good eye on it while it prints. And actually, as it gets started here, I'll go ahead and send it to the printer in just a minute. I'll record some video so that you guys can see the process as the printer gets started with its bed leveling procedure and its meshing and all of that stuff, because I don't think that when I built this Dragon Burner toolhead back, you know, in that original build series, I don't think we ever got far enough where it was printing reliably enough that I could show you guys kind of how that startup process works, the macros that I've created in Clipper to do, you know, the print start process. So I'll give you a look at that as we start printing this first one. All right, so the homing procedure is just as you would expect. It does X and Y with sensorless homing. And then that Z height probe that you just saw there is using the Beacon Probe in its proximity mode. So it's actually just getting down close to the bed and using its eddy magnetic sensor to sense the presence of the bed and get the height that way. Now it's going to move up and it's going to heat the bed and heat soak just for a couple of minutes, and then heat the nozzle up to 150 degrees, which is what I use for the rest of the sort of probing and leveling process. I am running this, at least for now, with the enclosure door open, just so that the camera can see inside for you guys to see this process. But of course, once it gets started printing, I will close that thing up, because the whole point here is to make sure that the Nitehawk works in those high temp environments with the enclosure closed. So this is kind of a weird sort of beginning here, because we're breaking the rules as far as heating the enclosure up without having the door closed. But again, I wanted to give you guys a view here of what this looks like as it gets started. So we'll fast forward through this heat up process, and then I'll show you how quad gantry leveling works and how the bed meshing works as well with the Beacon Probe. All right, so now it's doing the quad gantry level. Again, it's using the Beacon Probe in proximity mode, so the nozzle's never touching the bed, it's just getting down there kind of low. Tried to get you a low angle view with the camera so that you could see kind of under there and how that's working, but I'm not sure that it's quite low enough of an angle. Anyway, it'll go around 2 or maybe 3 times to make sure that the gantry is perfectly level and parallel with the bed before we continue. All right, looks like 2 times was all that was needed. Now it's doing the bed mesh. So you see the Beacon Probe here, it just goes back and forth over the area that's going to be printed, which in this case is a fairly large area because we're printing that big square piece. So it goes to the back of the bed and then it comes back to the front. So kind of 2 passes over the print area. And that computes the bed mesh. I'll show that to you in just a minute. Now it's actually using the Beacon Probe in touch mode, tap mode. So it's actually going down and very lightly tapping the nozzle on the bed. And this is to get its final Z height measurement so that it's very precise. Now it's moved up and it's going to heat the nozzle to printing temperature and then begin the print. And so at this point, I'm going to stop the camera so that I can close the enclosure and let the print do its thing. And here's the mesh that Beacon Probe calculated, at least for this particular print. So you can see there's a bit of a higher spot kind of in the middle toward the back, which is a thing I know about my print bed. That's always kind of been the case. The range here is 0.15-ish millimeters from the highest point to the lowest point. So it's not a huge difference, but I do have kind of a higher spot. And up here in the front part of the bed, which it didn't probe, there's a higher spot there as well. But that's pretty normal for my printer, my print bed. I think it has to do with how the plate expands as it heats. I get those 2 high spots kind of in the middle toward the front and the back. So anyway, that looks normal to me. Just wanted to give you a look at what happens with the Beacon Probe. And this is a, looks like 12 by 12 mesh that it chose for this particular print. And again, for a smaller area of print, it'll, you know, calculate a mesh for a smaller area of the bed. And sometimes it does it for the entire bed if you're printing a lot of things. So anyway, that's what the Beacon does. And now it's actually started printing. I can hear it in the background. And so hopefully we're getting a perfect first layer, which we tend to do when the Beacon works well. So we'll see how that goes. Once we get the print off of the bed, we'll take a look at what that first layer came out to look like. Okay, it is the next day for me. I've relocated over here to the build desk because all of these parts are printed and ready to assemble. So we're gonna do that now. But before we do that, I wanted to give you guys a kind of close-up view of some of the detail, the texture on this print. These things came out really, really good. They have this kind of subtle texture to them. They're not perfectly smooth. And this is the top side, so the top printed layer. And then if I flip it over, here's what the back side looks like. This was the side that was down against the print surface. And I don't think I mentioned it before, but I chose the Honey Badger satin print sheets that I have. That's the one that I chose to be my print bed for this one, because I thought that it would produce kind of a subtle texture that it was similar to what the top surfaces were going to come out looking like. And that worked excellently in this case. So I'm super happy with that. While all of these parts were printing on the Voron 2.4, I was printing the handles and feet as well on the Prusa Mark IV's. So I just used a PLA Pro that I happen to have that's kind of silvery looking. It's not super shiny or metallic looking, but I thought it might go with kind of the brushed aluminum look on the outside of the Mac computers and kind of, you know, add a little bit of an accent color. And so those were printed just in regular PLA. And the other thing I did while I was messing with that is I actually went and grabbed the original files and cut a little hole in the underside of the feet, because I went and found these things in my sort of craft junk drawer that I have, that I just have extra craft materials. And so this thing, these little felt sticky pads should be able to stick nicely right in there. So I'm going to do that on all 4 of the feet. And then I also need to put heat set inserts into the tops. There's this hole in the top of each of the feet. There's 2 that go in the handles as well, and then 4 of them that go here, here, and then same on the other side on this part here. So that'll be what we use to screw everything together. So I'm gonna get all of that prepared, and then we'll start assembling this thing. So with the parts prepared, I'm going to put the handles and feet on these top and bottom parts first. And there's one of these, yeah, it's this one here. The first layer didn't print well on this part. I'm not sure what happened. It was the same settings and everything as the rest of the parts, but this one doesn't look very good. So I'm gonna make this the bottom, which means I'm going to use the feet parts here. And so I've got some M3x6 screws. They just go down through these holes here and into those feet. So I'm gonna screw the feet in this one and then the 2 handles in this other piece, and that will become the top. Okay, so now I'm gonna start with the bottom piece here, and we're gonna put the front on. The front goes with the this hole here for the power light toward the top. So this goes this way, and this should slot on just over these curved tabs here. And eventually we'll put a screw through the side here, but we need the side panels in place as well. So that popped on nice and tight. All right, so 4 of these M3x20s, and this way is the bottom, so the Apple logo goes like so. And we'll go ahead and put this one through first because this will hold the front panel in place, and then we can go ahead and do this back one here. All right, I'm not gonna tighten them all down just yet. I'm gonna make sure that the case is square before I do that. I did notice when I pulled these Fiberon parts off of the printer that they seem like they bent a little bit, like they printed flat. They didn't warp during printing, but they seem to want to have a little bit of bend to them now that I've pulled them off of the printer. They all like wanted to bend just a little, but they're easy to bend back into place. So as I put the screws in here, they will hold everything square again. So I'm not concerned about the final product being bent. All right, and so now I will go ahead and put this top piece on as well. So once again, it just slots in like so. And this screw in the front corner here will go through both parts. So it goes through the top and then it goes through this part that's the front of the case as well. So once again, I'll use one of these longer ones and this will lock everything in and make sure it's all square. And before I tighten that one down, I will, just like I did with the back here, put the one screw through here to hold this in place as well. All right, that one's nice and snug. Now we'll snug up these two in the front corners. All right, that's looking really good. Let me get you a wider angle view here. So this is what the case is gonna look like. This is the front, this is the left side, and obviously the right side is open at the moment. This piece here will go on there to close it up. But first I have to put the computer and the external drive docking bay thing in place in here. So I'm gonna stack the USB enclosure first so that it lines up with this hole, and then the computer on top of that with the computer's venting pointing out this way, and then I'll screw this on. I'm not gonna show that on video because I use that computer for recording these videos, and so I'm gonna have to turn the computer off, obviously, to get it here in the case. So I'll put it in the case, then we'll come back and I'll show you what the final result looks like. And so, after a lot of rerouting of cables and kind of making a huge mess underneath my desk, which I will have to clean up later, this is the result. I've tried to pull this out here under the shot, under the camera as best I can for you guys to see. Obviously, this is designed to never be shown on camera, and so all of these cables back here are kind of stretched to their limits. And so I'm not sure how I'm gonna get you guys good angles of this. But anyway, one side of the case looks like this. The front is like this and has the nice ports. So this vertical section over here is the external hard drive enclosure with all of its SD card slots and other things that it has. And then this side over here is the Mac Studio computer itself. And then on this side, we've got this big opening for the exhaust vent to work. And I can't really show you the back because everything is plugged in and all the cords are pulled very tightly, but it's just open on the back so you can access this very nicely. So now this thing, instead of being kind of shoved behind one of my monitors on my desk here, can have a more prominent spot right up on the desk where I'll be able to kind of show off how nice it looks. And I think the case came out looking really, really good. So what did we learn today? I think first of all, the most important thing is the Voron 2.4 back there. I'm very confident now that the LDO Nitehawk-36 upgrade, the recalled board, the new version that they sent to me, works perfectly. So that thing is my workhorse printer, and I feel good now about being able to just, you know, send prints to it and be confident that it's going to work. This thing, I don't think I said earlier, but this case, all the parts for it ended up being somewhere between 15 and 16 hours of print time. All of that was not consecutive because there was an overnight in between, so I left a print going overnight, and then 5 or 6 hours later, the next morning, I started the next one. So it wasn't 15 hours of continuous printing, but it was like 10 and then 5 or 5.5 or something like that. And so I'm, like I said, very confident that the heating issues with the Nitehawk-36 board are, at least for me, solved. Second thing I learned is I really like this Voron filament. The external finish on it is amazing. It's extremely expensive though, so I'm not likely to use it for a lot of projects, and I don't have much left on the spool that I bought. I think it was like $35, and it's only for a 500 gram, so half kilogram spool. So yeah, it's definitely an expensive thing, but if you have need for it, or if you want to print something that just looks really amazing with this black kind of slightly textured finish, it's a good choice, as long as you have a hardened steel nozzle and a printer, you know, capable of printing it. So with that, I think I'll end this one. This was a fun project, and more than that, a good test of the new, you know, LDO Nitehawk replacement. And like I said, I'm super happy, and I'm glad that that works well. And so now that thing can go back to being the workhorse printer that it has been here in the studio, and I'm excited for that. So I will see you guys next time. I think probably what I've got coming up next for you that I owe you is a review of the Prusa Mark IV's. And so I've been printing with that for almost a month now. So I feel good about having some thoughts that are hopefully coherent and I think complete on what I think of that printer. It's been mostly good, just as a preview. There have been a few things that I don't really like that much about it. And we'll talk about that in the next video, which will be a review of the Mark IV's. Until then, I hope you guys have a good day, and I'll see you next time.